Hey everyone, welcome back. Today's our topic of discussion is frequency distribution. Already in the previous class, we have discussed that data need to be classified in order to have a easily presentable form. It is divided into two forms. One is textual form and the other one is tabular form. For tabular form, it is either represented in the form of a frequency distribution or in the form of graphical or diagrammatical method. In the frequency distribution, we need to know what the word frequency is. Frequency is nothing but the number of times a value is repeated in the given data. And frequency distribution is the presentation of the complete data in the form of a table where the frequency of each value is represented. The other one is diagrammatic or graphical representation, where the data is represented in the form of a picture, which is further discussed in the next class. And for textual formation of representation of data, you can refer the previous video. Now let us delve deep into what frequency distribution is. Frequency is the number of times a given value is repeated in a particular data. And frequency distribution is the presentation of the complete data in the form of a table where the frequency of each value is represented. And basis on this frequency distribution, the data is divided into three types. The first one is raw data, the second one is discrete or ungrouped data, and the third one is continuous or grouped data. See, sometimes what happens is the data may be very limited or easily understood, and sometimes the data may be very large. So when data is limited, we can go for raw data or discrete data. And when the data is large enough, we can go for continuous data. When the data is limited, we go for raw or discrete data. But what is the difference of these two? In raw data, every value is unique. It doesn't repeat itself. In continuous or grouped data, the data is very large. So, to represent that large data into a single table, we first divide the data into different class intervals, which are nothing but groups. And we see that each and every value falls in either of these groups. That is the reason why the grouped data is mutually exclusive, exhaustive, and non-overlapping. Here we see that each and every value in the data falls in any of the intervals that we divide. Now we see what is the construction of a frequency distribution and how the data falls under these three categories with respect to some examples. Now in this example, suppose my data is like this. I have 10 values, 20, 18, 15, 17, 8, 9, 4, 19, 11, 10. The data is limited, just 10 values are there. But we can observe that here every value is unique. It is not repeating. So this is called as my raw data. Here the tabular representation will be, the variable will be represented as x and all my values will be given. 20, 18, 15, 17, 8, 9, 4, 19, 11 and 10. That is it. This will be my frequency distribution with respect to raw data. So my criteria is satisfied, right? Here my data is limited, only 10 values are there, and similarly none of the values are repeated. This is my raw data. Similarly, with respect to ungrouped data, I can see that my data here is also limited, where only 20 values are there that are like this, but we can see that here the values are repeating themselves. 20 is repeating 4 times, 15 is repeating 1, 2, 3 times, 14 is repeating 3 times, 17 is repeating 3 times, 8 is repeating 4 times. So all values are repeating more than once. In such situation, we can frame it into ungrouped frequency distribution. We'll form the table as x will be the value. and f will be the frequency or number of times the value is repeating. So x values will be 20, which is repeating 5 times. So my f is nothing but the frequency. Notations will not change. The values will always be x and f will always be frequency. The variable name will not change here. So 20 is repeating 5 times. Then it is 15. 1, 2, 3, 3 times. Next is 14. 1, 2 and 3. Next is 17. 1, 2, 3. Next is 8. 1, 2, 3, 4. Next is 11. 1. 11 is repeating only 1 time. Its frequency value is only 1. And finally it is 19. 19 is also repeating only 1 time. So this is my frequency distribution with respect to discrete or ungrouped data. And sum of all my frequencies should be the number of values in the given data. The sum of all the frequencies should be the number of values in the given data. 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14, 14 plus 4, 18, 19 and 20, which is nothing but the number of values in the given data. This is ungrouped frequency data. Here, in this frequency distribution, this is possible only when the data is very limited, when the data is accessible enough to present it in the form of table. If the data is very large, where the ungrouping cannot be done, in such situation, we group the data to form the continuous or grouped frequency distribution. Now let me explain the continuous or grouped frequency distribution, but with only limited data, because here we cannot do it for large amount of data. We'll take an example with only 20 values and show you how the grouping of the data can be done. Right? Now here we have 20 values. First, initially what we need to do is we need to see the range of that particular data. Range is nothing but the highest value in that data and the least value in that data. So first, what is my highest value? Highest value here is 70. Highest value is 70 and the least value is 22. So range will be 70 minus 22, which is nothing but 48. 48 will be my range. So first step in the construction will be finding out the range. Before finding out the range, what I have done is I have arranged the data in the chronological order. That is from the least to the highest or highest to the least. First arrange the data in the chronological order and then find the range of the data, that is the highest value minus the least value. Once we have found out the range of this data, we can identify the number of class intervals the data can be divided. We see that there is a total of possibility of 48 values occurring between these two. So based on this range only, we find out the number of class intervals the data can be divided into. Number of class intervals or groups the data can be divided into as 5. I take 5 groups where the total data is divided into. Now, what is the width of each group? Magnitude or width of each interval. Now, since we have seen that the data is arranged in chronological order or increasing order, then we found out what is the range of that particular data. Then we have seen that the number of class intervals may be 5. Now we need to see the size or the width or the magnitude of each interval. The magnitude can be from 2 to 20. It depends upon the size of the data, the vast amount of data. I have seen that my width of the class interval can be 10 because the range is 48, the data is increasing. So to reduce the size of the table, I can increase the size of my class interval from 5 to 10. So 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 to 70. Now observe the data here. The number of values that falls between 20 and 30 are 1, 2, 3, 4. Yes, from 30 to 40, since 30 is already included in this interval, I go from 31 to 40 here. So from 30 to 40, we have 1, 2, 3, 4. Now 40 to 50, I have 1, 2, 3, 4. 50 to 60, 1, 2, 3, 4. 60 to 70, I have 1, 2, 3, 4. So in each interval, I have 4 values. See, 25 value falls only in one interval and it doesn't appear in other intervals. Similarly, 68 falls only in the interval 60 to 70 and it doesn't falls in other intervals. This it says that the all values should be mutually exclusive and non-overlapping. This is how the data is grouped in order to form the frequency distribution. Here, similar to the ungrouped distribution, the sum of all frequencies should be equal to the number of values in the given data. Since we have seen what frequency distribution is, the other form of tabular representation is nothing but diagrammatic or graphical representation of data. The name itself suggests that here the data is represented in the form of a diagram or a graph or a chart so that the complex data can be understood at a single glance. First of all, let me explain what a graph is and how it needs to be constructed. It is the combination of two lines, that is the two axes. This is x-axis and this is y-axis. They intersect at a point O, which is nothing but origin. On x-axis, we represent the values of our data, and on y-axis, we represent the frequencies of each value. Here, the x values will be there, and here we have the frequencies. Now, for representing data on this graph, we generally have different types of graphs like line graph, bar graph, histogram, frequency polygon, and pie charts. Let us discuss deep with respect to each and every graph. The first one is bar graph. In this graph, we describe data in the form of graphs. There are, in general, 3 types of graphs that are used in the form of bars. The first one is simple graph, the second one is multiple bar graphs, and the third one is stacked bar graphs. The first one is simple bar graph. A bar graph should have the following rules to be followed. Each bar should be of same size, space between each bar should be the same, and height of the bar represents its value or frequency. These are the 3 rules that need to be considered before a bar graph is formed. Suppose this is my example of a student who has scored in English, Maths, Social and Science. His English marks are 15, Maths marks are 40, Social marks is 30 and Science marks is again 40. So if you want to describe your data in the form of a graph like this, we can construct a bar graph. Here, the size of each bar should be same. The space between each bar should be same. This is your simple bar graph. Now let us see an example with respect to multiple bar. I have the same student that I have considered in simple bar graph. That was his test 1. And now we compare his result with respect to test 2. For English, test 1, test 2 marks. Maths, test 1, test 2 marks. And Science, test 1, test 2 marks. Social, test 1 and test 2 marks. Their marks are given on the y-axis and the subject is given on x-axis. Here, the multiple bar graph is easily represented to compare his test marks in test 1 and test 2. The next one is stacked bar graph. Let us consider an example where two families are considered of almost same monthly income, that is family 1 and family 2. So in stacked bar graph, we consider the complete bar as 100 and we divide the parts of this bar into different sections. Here we have divided it into 4 sections. The first one is fuel, the second one is food, the third one is rent, and the fourth one is utility. That means the entire income is divided into 4 groups that they spend. The first one is fuel, food, rent, and utility. And we divide it in this way. We have considered for family 1, till this place it is for fuel. Then from this to this part it is food. From this to this part it is spent on rent, and the leftover part is spent on utility. Expenditure spent on fuel, food, rent and utility has proportionately varied for family 2 with respect to family 1. This can be observed on the basis of stacked bar diagram. This is also for comparison purpose. The next example is of pie chart. In the stacked bar diagram, we have considered the whole as 100 and we have seen each and every part as the proportionate of 100 in stacked bar diagram. And in stacked bar diagram, we have used it for comparison purposes. But whereas in pie chart, this is not for comparison purposes, but for a pictorial representation of a single family in this example. Here, my whole component is of 360. It is considered as 360 and the proportionate of each value, the proportion of each value is considered with respect to 360. Here, it is divided, the pie chart is divided into food, fuel, rent and utilities, and it is percentage and it is represented in percentage of the whole. The next one is for histogram. There is a small difference between histogram and bar graph. In bar graph, the data can be quantitative or qualitative. That is, it can be categories or numbers. Whereas in case of histogram, the data is only quantitative and it should be continuous in nature. Here, the bars are attached to each other. That is, there is no space in between the bars. But yes, the height of the bar represents the value and the width of the bar should be same. The only difference between the bar graph and histogram is that in bar graph, there is a space between each bar and in histogram, there is no space between each bar. The bar graph is for either quantitative or qualitative data, whereas histogram is only for quantitative data, that too continuous quantitative data. Let us consider an example where the data is divided into 6 class intervals and the width of each class interval is 5 here. So, from 0 to 5, there is a repetition of 2. From 5 to 10, 2 values are there. 10 to 15, 5. 15 to 20, 5 values. 20 to 25, 3 values. 25 to 30, 3 values. This is a group data where the data is divided into 6 intervals with class width of each 5. 0 to 5, 5 to 10, 10 to 15, so on. Now for histogram, we have already discussed that there will not be any space between the bars and the size of each bar should be same. Why is there no space between the bars? Because the upper limit of this interval will be the lower limit of this interval. So here there is an overlap of the limits in each intervals. That is the reason why it is a continuous distribution presented in the form of a histogram. So from 0 to 5, it is 2. 5 to 10, it is 2. 10 to 15, it is 5. 15 to 20, it is 5. 20 to 25, it is 3. And similarly, 25 to 30, it is 3. For frequency polygon, first we need to construct a histogram for the given data and simply join the midpoints of the bars. This is my frequency polygon. Join the midpoints of the bars and with that will give you the frequency polygon of the given data. Thank you for watching. With this, we have completed the topics frequency distribution of data and graphical presentation of data. The introduction to statistics topic is completed with this. In the next video, we'll be discussing about measures of central tendency, which is the unit 2. Thanks for watching and all the best.